In this video, we're going to talk about derivatives of trigonometric functions. Let us look at the basic formulas. With the derivative of sine x would be cos x. Derivative of cosec x would be minus cosec x times cot x. The derivative of cos x would be minus sine x. The derivative of sec x would be sec x times sine tan x. The derivative of tan x would be sec square x. The derivative of cot x would be minus cosec square x. And we have a bunch of formulas here for the inverse trigonometric functions as well. So now, while solving these derivatives of trigonometric functions, we're going to use our product rule, our quotient rule, and chain rule that we looked into in our previous video. Example number 1. We have to find the derivative of function y if it's equal to sec 4x. Here, let us suppose the variable 4x be equal to u. Then our function y with respect to u would be sec u, and our variable u with as a function of x would be 4x. Then, so using chain rule, what we can do is we can find dy with respect to dx such that dy, which is the function of u respect to du, and the derivative of du with respect to x. So this would give us dy function of u is sec u with respect to u, and times the derivative of u, which is 4x, divided by dx. So now derivative of sec x is sec x times tan x, which is the formula that we looked into earlier, times derivative of 4x would be 4. Now substituting this value of u into this, we get our answer dy by dx equal to 4 times sec 4x times tan 4x. Example 2. If y equals to tan 3x minus cot 3x, what would be the derivative dy by dx? Now we know from our first video that we can, if we are to find dy by dx for the terms which are in addition or subtraction, we can find the individual derivative of those functions, right? So it will be d tan 3x by dx minus d cot 3x by dx. So here the variable 3x is common in both the functions, or both the trigonometrical functions. So let us suppose u1 equals to u2 equals to 3x. Then our value of y with respect to u1 would be equal to tan u, and y with respect to u2 would be equal to cot u. This chain rule, d tan u divided by du times d u1 is 3x divided by 3x minus d cot u by du times d u2 is 3x divided by dx, which gives us the derivative of tan u is, we looked earlier in the formula, it's sec square u times derivative of 3x would be 3 times x to the power 1 minus 1, which would be 0, so it would only be 3, minus derivative of cot u would be minus cosec square u times derivative of 3x is 3. So simplifying this, 3 sec square u plus 3 cosec square u. Now substituting the value of u1 and u2 into here, which is u1 and u2, we would get our answer 3 sec square 3x plus 3 cosec square 3x. Let's look at example number 3. If we have y equals cot 5x plus cosec 5x. This is the function which is pretty much similar to example number 2 we looked at. So let us assume y1 equals to y2 equals to 5x. Then our variable or function y with respect to u1 would be cot u, and then y with respect to u2 would be cosec u. Then applying chain rule, if we are to find dy by dx, then we would be applying chain rule in such a way that your dy with respect to u1 times du1 with respect to x plus dy respects to u2 times du2 respect to x, right? It's just a matter of substituting those values. So your yu1 is cot u divided by du1 times your du1 is 5x with respect to dx plus yu2 is cosec u with respect to u2 times your du2 is 5x again with respect to x. So we know that derivative of cot u is minus cosec square u times the derivative of 5x would be 5 plus derivative of cosec u is minus cosec u times cot u times the derivative of 5x is 5. So simplifying this, we get minus 5 cosec square u1 plus, or let's say minus 5 cosec u2 times cot u2. So substituting the value of u1 u2 in this, we get minus 5 cosec square 5x minus 5 cosec 5x times cot 5x. If we take 5 minus 5 cosec 5x common out of this equation, we will have cosec 5x plus cot 5x. So example number 4, if we have y equals to cosec cube twice x. So I'm going to put this as a challenging question. Hint, you can use chain rule, and if we have sine cube x, then this can also be written as sine x whole cube. So example number 5, so we have y equals to 3 sec x times 10x. Now what you can see is we have a constant number, we have first term, let's say this is f, and second term, let's say this is g. Then which formula or which rule can we use? We can use product rule, right? So what product rule says is, if we recall the formula that we talked about in previous video, if we are to find the derivative of any product f times g with respect to x, then it would be z the derivative of f in terms of x plus f times derivative of g in terms of x. Now substituting the values, let's put the constant outside. Then g is 10x times derivative of sec x with respect to x plus sec x times derivative of 10x with respect to x. 3, we have 10x times derivative of sec x is sec x times 10x plus sec x times, if you look at the formulas that we talked earlier in this video, derivative of 10x we can find is sec square x. Now if you simplify this, we'll have sec x common, and in the bracket we will have 10 square x plus sec square x. The example of trigonometric functions where we can apply product rule. Say we have cos x times y equals to cos x times cot x. Now the first term be f, second term be g. Then according to product rule, again, if we find the derivative of f times g with respect to x, this would be g df by dx plus f times dg by dx. So our g is cot x times derivative of f, which is cos x, plus f, which is cos x, times derivative of g, which is cot x with respect to x. So this would be cot x. If you look at the formula that I presented in this video earlier, derivative of cos x is minus sin x plus cos x times derivative of cot x would be cosec square x. Now if you simplify this, minus sin x times, we know cot x is cos x by sin x, so our sin x will be cancelled, plus cos x minus cosec square x. So this would be, if we take minus cos x common, then in the bracket we would have 1 plus cosec square x. Look at another example, example number 7, where we can actually apply the quotient rule for derivatives of trigonometric functions. Say we have y equals to sine x divided by x, then our numerator be f, function f, and denominator be function z. Then according to quotient rule, if we have to find the derivative of the functions which are divided with respect to x, then it will be g times df by dx minus f times dg by dx whole divided by g square. So our g function is x, and then f would be d sine x by dx minus f, which is sine x, times derivative of function g with respect to x divided by g square, which is x square in our case. So x times derivative of sine x is cos x minus sine x, derivative of x is 1 by x square, which is x cos x minus sine x divided by x square. There's one more challenging question for you, example number 8. So we have y equals cot x divided by 1 minus sine x. Then how do you find the derivatives of these trigonometric functions using quotient rule?